Hi everyone, today we are going to start 8.4, which is properties of rhombuses, rectangles, and squares. Three special types of parallelograms. The first one is a rhombus, and a rhombus is a parallelogram with four congruent sides. Our next parallelogram is a rectangle, and a rectangle is a parallelogram with four right angles. And our last special type is a square. And a square is a parallelogram with four congruent sides and four right angles. So here's our little diagram of parallelograms. So we would see that we have rhombuses, which means they have four congruent sides. We have rectangles, which have four right angles. And then squares. We see that a square is also a rhombus, and a square is also considered a rectangle. But a rectangle is not a square, and a rhombus is not a square. So properties of a rhombus. We know that the definition is that all four sides are congruent. We also know that the opposite sides are parallel, the opposite angles are congruent, the diagonals are perpendicular bisectors of each other, and the diagonals bisect angles. And lastly, we have two lines of reflection symmetry. So here's what a rhombus looks like. Properties of a rectangle. By definition, we know that a rectangle has four right angles. Some more properties is that the opposite sides are parallel, opposite sides are congruent, the diagonals are congruent, the diagonals bisect each other, and we have two lines of reflection symmetry. And so here's our example of a rectangle. Finally, properties of a square. By definition, a square has four right angles and four congruent sides. So our properties are the opposite sides are parallel, diagonals are congruent, diagonals are perpendicular bisectors of each other, the diagonals bisect the angles, and we have four lines of reflection symmetry. And there's our example of a square. So for our first example here, for any rhombus, ABCD, decide whether the statement is always true or sometimes true. To answer these questions, make sure you have your properties out that you just wrote down from the previous slides, and we should now be looking at a rhombus. All right, so number one says that ABC, which is this angle right here, would be congruent to CDA, this angle right here. When is that true for a rhombus? Is it always true or sometimes true? Well, this is always true. And if you look back at your properties of a rhombus, we know that the opposite angles are congruent. Now let's look at number two. Number two states that CA is congruent to DB. So CA would be this diagonal, and DB would be this diagonal here. So when is this true? Is it always true or sometimes true that the diagonals in a rhombus are congruent? Well, this answer would be sometimes. Why? If you look at your definitions and your properties of a rhombus, you won't see that the diagonals are congruent. However, if you look at a square, you'll see that one of the properties is that the diagonals are congruent. And we know that a square is considered a rhombus by definition. So for number two, once again, it's sometimes true and only if it's a square. For any rectangle, FGHJ, decide whether the statement is always true or sometimes true. All right, so here's our rectangle. Make sure you're looking at your properties of a rectangle that you wrote down. And when is it true that angle F is congruent to angle H? Well, that would always be true. Why? Well, by definition of a rectangle, you have 4 right angles. So angle F would be 90 degrees and angle H would be 90 degrees, meaning that they are congruent. Next, GH. So GH is here, and HJ, which is right here. I guess this should be a J. When would those be true? Always or sometimes? This answer is sometimes. And once again, the only way that this would be true is if this rectangle was a square. So this is sometimes true, and it would be true if it's a square. Classify the quadrilateral and then explain our reasoning. So we want to know, is this a rhombus, is it a rectangle, or is it a square? So looking at number 5, if you look at this, we notice that our sides are congruent. So this gives us 2 options. It's either a rhombus or a square. But looking at this, which one do we know it is? We know that it's a rhombus. Why? Well, this angle is 91 degrees, and a square has 4 right angles. So since we see that this is 91 degrees, the only option is that this is a rhombus. All right, let's look at number 6. So number 6, what type of quadrilateral do we have here? A rhombus, a rectangle, or a square? Well, the answer is a square. How do we know that? Well, if we look, we have 4 congruent sides. We also notice that we have right angles. And since this is a quadrilateral, we know that the 2 angles here are supplementary. So if this angle is 90, this angle is also 90, and this angle has to be 90. So since it has 4 congruent sides, 4 right angles, we then have a square. Name each quadrilateral, either a parallelogram, rectangle, rhombus, and a square, for which the statement is true. Once again, I would get out your properties. That will help you to answer these questions. All right, so the first one, it is an equilateral. So equilateral means all sides are congruent. So which one does this work for? It works for a rhombus and a square. Next, the diagonals are congruent. There's 2 of them for this. What are they? It would be a rectangle and a square. Next, it contains obtuse angles. Remember, the word obtuse means greater than 90 degrees. Once again, there are 2 answers for this one, and it would be a parallelogram and a rhombus. And our final question here contains no acute angles. Remember, acute means less than 90 degrees, and so this would be a rectangle and a square. And if you think about those 2, both of those have 90-degree angles. All right, next, classify the special quadrilateral, explain your reasoning, and then find the values of x and y. All right, so let's start with the easy question. What type of quadrilateral do we have here? Is it a rhombus, is it a rectangle, or is it a square? The answer is a square. And we see that because we have 4 congruent sides and we have 4 right angles. Now let's solve for x and y. Well, if the side lengths are congruent, that means I'm going to set these equations equal to each other because they are congruent. So let's start with x. I have 5x minus 4 and 3x. So 3x is equal to 5x minus 4. All right, so if I subtract 3x, subtract 3x, that gives me 0 is equal to 2x minus 4. Add 4, add 4. I get 4 is equal to 2x. Divide by 2, then we get 2 is equal to x. Next, let's solve for y. So I want to set those two equations equal to each other. And I have 5y plus 1 is equal to 2y plus 4. Subtract 2y from each side. I get 3y plus 1 is equal to 4. Subtract 1 from each side. 3y is equal to 3. Divide by 3y is equal to 1. And our last question for today, let's start with what type of quadrilateral do we have here? Is it a rhombus, a rectangle, or a square? The answer is a rhombus. How do I know it's a rhombus? Well, I see my 4 sides are congruent, and I know that one angle is 127, which means it can't be a square. The only option is a rhombus. All right, so let's solve for x and y. So let's remember that the definition of a parallelogram is that your consecutive angles, which would be s and t for this example, are supplementary to each other. So that means I'm going to take 2x minus 1 plus my angle t, which is 127, and I'm going to set that equal to 180. Combine your like terms, and we get 2x plus 126 is equal to 180. Subtract 126 from each side. We get 2x is equal to 54. Divide by 2. X is equal to 27. Now let's solve for y. If we look at the y's, we see that they're on the sides. And for a rhombus, our sides are congruent. So I'm just going to set 6y minus 5 is equal to 3y plus 7. Subtract 3y from each side. I get 3y minus 5 is equal to 7. Add 5 to each side. 3y is equal to 12. Divide by 3. Y then is equal to 4.